NFPA 110 outlines the testing requirements for emergency power on standby systems. These requirements are designed to ensure the reliability and performance of these critical systems. Testing is performed at several stages, including initial acceptance, recurring intervals, and after repairs or overhauls. Initial acceptance testing involves witnessing and recording the startup and operation of all transfer switches, generators, and related equipment. Load bank testing is performed to verify the specified output at various load levels. Synchronization and paralleling tests are conducted if applicable. Functional tests are performed on all controls, electrical interlocks, and indicators. All test results are recorded and documented for future reference. Recurring inspection and testing include monthly, annual, and 5-year intervals. Monthly inspections include exercising all transfer switches and verifying automatic and manual operation. The battery voltage and electrolyte level are checked if applicable. Annual inspections, performed at 12-month intervals, include load bank testing at 50% and 100% load for 30 minutes each. Synchronization and paralleling tests are conducted if applicable. All automatic starting and shutdown sequences are tested. All electrical connections are inspected and cleaned. Every 5 years, a complete inspection, testing, and maintenance is performed on the system. The generator fuel system, including the fuel tank, fuel lines, and injectors, is verified. A thorough engine inspection is conducted. All protective devices, such as overcurrent and overspeed, are tested. Performance testing is required when a generator is repaired or overhauled. This testing ensures proper performance after the repair or overhaul. Fuel tank testing is required every 10 years. Fuel storage tanks are tested for leaks and corrosion. Hydraulic governor testing is required every 5 years. Hydraulic governors are tested to ensure proper operation. Generators installed in underground enclosures must be tested for waterproofing integrity every 5 years. Documentation and reporting are crucial aspects of NFPA 110 compliance. All test results must be documented and kept on file for future reference. The battery maintenance log must be reviewed and updated as necessary. Any repairs or maintenance performed on the system must be recorded. To delve deeper into the specifics of each test, consider the following points. Firstly, regarding load bank testing, this process involves connecting a load bank to the generator to simulate real-world load conditions. The generator's performance is then monitored under these controlled conditions. The load bank allows for the adjustment of the load in increments, allowing for the evaluation of the generator's ability to handle varying demands. Parameters such as voltage, frequency, current, and power output are measured and recorded during the test. This data provides valuable insights into the generator's overall health and ability to meet its rated capacity. Secondly, synchronization and paralleling tests are essential when multiple generators are intended to operate in parallel. Synchronization ensures that the generators are operating at the same voltage, frequency, and phase angle before being connected to the same bus. Paralleling involves connecting the synchronized generators to the bus, allowing them to share the load. These tests verify that the synchronization and paralleling equipment functions correctly, preventing damage to the generators and ensuring a stable power supply. Thirdly, automatic starting and shutdown sequence tests verify the proper operation of the generator's control system. These tests simulate power outages and other emergency conditions to ensure that the generator starts automatically and assumes the load within the specified time. The tests also verify that the generator shuts down automatically when the power is restored. Fourthly, fuel system verification involves inspecting the fuel tank, fuel lines, and injectors for leaks, corrosion, and other damage. The fuel level is checked and the fuel is tested for contamination. The fuel injectors are inspected and cleaned to ensure proper fuel delivery. These tests ensure that the generator has a reliable fuel supply and can operate for the required duration. Fifthly, engine inspections involve a thorough examination of the engine components, including the cylinders, pistons, valves, and crankshaft. The engine oil level and condition are checked. The cooling system is inspected for leaks and proper operation. These inspections identify potential problems before they lead to engine failure. Sixthly, protective device testing involves verifying the proper operation of overcurrent, overspeed, and other protective relays. These relays are designed to protect the generator from damage in the event of a fault or overload. The relays are tested to ensure that they trip at the correct settings and isolate the generator from the system. Seventhly, battery maintenance is crucial for ensuring the reliability of the generator's starting system. The battery voltage and electrolyte level are checked regularly. The battery terminals are cleaned to prevent corrosion. The battery is replaced when it reaches the end of its service life. Eighthly, documentation and reporting are essential for maintaining a record of all testing and maintenance activities. This documentation can be used to track the generator's performance over time and identify potential problems. The documentation is also required for compliance with NFPA 110 and other regulations. In addition to the specific tests outlined in NFPA 110, there are other factors to consider when testing emergency power systems. These factors include the ambient temperature, humidity, and altitude. These environmental conditions can affect the generator's performance, so it is important to take them into account when interpreting the test results. The qualifications of the personnel performing the testing are also important. The testing should be performed by qualified technicians who have the knowledge and experience to properly operate the equipment and interpret the results. The use of calibrated test equipment is essential for obtaining accurate and reliable test results. The test equipment should be calibrated regularly to ensure that it is functioning properly. Finally, the safety of the personnel performing the testing should always be a top priority. The testing should be performed in accordance with all applicable safety regulations. Proper personal protective equipment should be worn at all times. Understanding the specific requirements for each test is critical for ensuring compliance with NFPA 110. Let's delve into more detail about each stage. For initial acceptance testing, it is vital to have qualified personnel witness and document the entire startup and operational sequence of the transfer switches, generators, and all related equipment. This includes verifying the proper functioning of all controls and safety mechanisms. During load bank testing, the generator must be subjected to varying load levels to confirm its capacity to deliver the specified output. It is crucial to monitor parameters such as voltage stability, frequency regulation, and temperature rise. When conducting synchronization and paralleling tests, if applicable, it is important to confirm that the generators can seamlessly synchronize and share the load without causing instability or disruption to the system. As part of functional tests, all controls, electrical interlocks, and indicators should be thoroughly tested to ensure they respond correctly to various input signals and operating conditions. It is imperative to meticulously record and document all test results, including measured values, observations, and any anomalies encountered, for future reference and comparison. For recurring inspection and testing, specifically monthly checks, exercising all transfer switches is necessary to verify the smooth and reliable operation in both automatic and manual modes. Battery voltage and electrolyte level checks, when applicable, are essential to ensure the availability of sufficient starting power for the generator. The annual inspection and testing phase, conducted at 12-month intervals, involves performing load bank testing at 50% and 100% load for 30 minutes each. This assesses the generator's ability to sustain its rated output under varying load conditions. The synchronization and paralleling tests, if applicable, are repeated to confirm the continued proper functioning of the synchronization and paralleling equipment. During the testing of automatic starting and shutdown sequences, the generator's response to simulated power outages and recovery events is assessed to ensure its reliable operation. The inspection and cleaning of all electrical connections are performed to prevent corrosion, reduce resistance, and ensure reliable power transfer. During the 5-year inspection and testing cycle, a comprehensive inspection, testing, and maintenance program is implemented for the entire system. The generator fuel system, including the fuel tank, fuel lines, and injectors, is thoroughly inspected for leaks, corrosion, and proper operation. A comprehensive engine inspection is conducted to assess the condition of internal components such as cylinders, pistons, valves, and bearings. Testing of all protective devices, including overcurrent, overspeed, and undervoltage relays, is performed to verify their correct operation and ability to protect the generator from faults. In addition to these recurring inspections, performance testing is required whenever a generator is repaired or overhauled. This testing ensures that the generator meets its original performance specifications after the maintenance work has been completed. Fuel tank testing is typically performed every 10 years to check for leaks, corrosion, and structural integrity. Hydraulic governor testing is required every 5 years to verify the proper functioning and responsiveness of the governor, which regulates the engine's speed. For generators installed in underground enclosures, waterproofing integrity testing is performed every 5 years to prevent water ingress and ensure the continued safe operation of the generator. Meticulous documentation and reporting are essential for maintaining a complete history of all testing and maintenance activities. All test results must be documented, signed, and dated, and kept on file for future reference. The battery maintenance log should be reviewed and updated regularly to track battery performance and maintenance. Any repairs or maintenance performed in the system must be recorded in detail, including the date, description of the work, and the name of the person performing the work. The specific parameters to be measured and recorded during testing will depend on the type of test being performed. For example, during load bank testing, the following parameters should be measured and recorded: voltage, current, frequency, power factor, kilowatt, kilovolt ampere, kilovolt ampere, reactive, engine speed, oil pressure, coolant temperature, exhaust temperature, and vibration. During synchronization and paralleling tests, the following parameters should be measured and recorded: voltage, frequency, phase angle, synchronizing current, and load sharing. During automatic starting and shutdown sequence tests, the following parameters should be measured and recorded: starting time, transfer time, voltage dip, frequency dip, and shutdown time. The acceptable limits for each parameter should be clearly defined in the test procedure. Any parameter that falls outside of the acceptable limit should be investigated and corrected. The frequency of testing should be based on the manufacturer's recommendations, industry standards, and the criticality of the application. For critical applications, such as hospitals and data centers, more frequent testing may be required. The testing should be performed under the supervision of a qualified engineer or technician. The test personnel should have the necessary training and experience to perform the test safely and accurately. The test equipment should be properly calibrated and maintained. The test equipment should be suitable for the type of test being performed. The test procedure should be clearly written and easy to follow. The test procedure should include all of the necessary steps, parameters to be measured, and acceptable limits. The test results should be documented in a clear and concise manner. The test report should include all of the necessary information, such as the date of the test, the location of the test, the equipment tested, the test procedure used, the test results, and the conclusions.